Newton's third law states when one object is pushed into another object, the second object pushes back an equal amount in the opposite direction. So this third law is super useful if you had like two objects clashing together, so like this. Or it could also be used in more practical situations like to find acceleration. One situation this is present at could be Agnes, who's 20 kilograms, is at rest on a scooter that is 35 kilograms. If she pushes against the ground with 25 newtons of force, what will her acceleration be? So Newton's third law is able to be applied here because, for example, let's say this is Agnes here on the scooter. And so she is pushing on the ground with her foot right here, and she's pushing back and then going this way. So it shows that when her foot makes contact with the ground, she's getting an equal reaction the other way as she pushes off. So if she pushes off really fast, the scooter's going to speed ahead. If she doesn't push back with as much intensity, the scooter will not move as much. So in order to calculate for this, it can be seen in the exact same way as the second law, which is that F net, which is the total amount of force, can equal the mass times the acceleration. However, this one is very different from Newton's second law because for multiple reasons. The first reason is F net, which is what we were solving for in the first one, can be easily found in the equation. It's given. So 25, we know that she's pushing off the ground with 25 newtons of force. So 25 equals, and then in order to find the mass, another difference is these two here. So to find out what her total acceleration be, it's important to know the amount of mass that is having to be moved. So that is the 20 kilograms that Agnes weighs, plus there's 35 kilograms that the scooter weighs, which is 55 kilograms. So 55 would go here, and then we're solving for the acceleration still. From there, it's the same thing. So you divide 55 on both sides because we're solving for A. 25 divided by 55 is roughly 0.45. So this is very important to know because it helps calculate very practical situations like this, and also shows how Newton's third law is associated with many things that maybe you didn't first know.